For our capstone project, we wanted to create something that could actually make a difference. Growing up, I watched my cousin live with diabetes, stress over every meal, every dose, crazy money spent, and painful finger pricks. And I know like him, there's millions worldwide waiting for a better solution. So as engineers, we took their story as a mission, and more than that, a responsibility with DiaBEAT.
In our quest for the ideal sensor for DiaBEAT, we decided to tackle the three main technologies that shape advanced CGMs. Our research started with fully invasive sensors, but they were painful and can cause a high risk of infection. We then explored minimally invasive sensors, but they were costly and unreliable. We were not satisfied with these solutions because they were not what we're looking for, nor the change we're trying to make. We want something that's painless, reliable, and accessible. So we dug deeper into research until we found our perfect match, a non-invasive sensor based on NIR light emission.
Next, we moved to the chemistry lab, where we worked with controlled glucose samples. We collected readings and studied how light interacted with different glucose concentrations. Our goal was to validate our hypotheses as a measurable correlation. And after many trials, the data revealed a clear pattern supporting the feasibility of our non-invasive glucose measurement approach.
Once the concept was validated, we moved to the hardware implementation, designing the housing to our electrical components and making the device wearable. Via the 3D printing done in our labs, we took our concept into a physical prototype. Then the assembly came with the circuit integration and intensive testing. At that point, the lab became our second home.
Now I will walk you through how DiaBEAT came to be. It is a system of 3 modules connected together. First, we have the bracelet. It tracks glucose through the skin completely non-invasively and sends the data via Bluetooth. Next, we have the belt. It receives this data, pumps personalized insulin doses to the patient automatically. And third, we have the mobile application, which connects all of those modules together via Bluetooth. The mobile application allows the patient to see real-time glucose levels, insulin injections, they can track their meals, they can track their history, and they can check the battery of the belt and the bracelet all on one screen like no other system. Now we can say that we have a fully integrated system that mimics a human pancreas. Our goal was clear. It was one fully connected experience, from monitoring all the way to treatment without any single finger prick.
The next step for DiaBEAT is to move from concept validation into real-world testing and refinement. We aim to improve the system's usability, accuracy, and integration into everyday patient care. By continuing to merge engineering innovation in addition to healthcare needs and patient-centered design, DiaBEAT can turn into a tool that can support better monitoring and more specialized diabetes management.